Welcome back to An Old House, Linux edition. Definitely not the old house, or this house which happens to be old, but also is going to run Linux. So, for those of you just tuning in, you know, everything's running fine at the office. Pretty busy, honestly. I mean, all things considered for IT, but we're doing some home networking, some home rewiring, got some helpful hints for you. This is my 48 port 10 gig switch. It's heavy, it's brick-like. 48 10 gig ports and 4 40 gig ports. It's the older standard. I'd love to have a 25/100 gig connection. Got a lot of stuff in my house that needs 10 gig connections. Truth be told, it's home plus office. So there's some, you know, office machines in there too. But you think about it and it's like, that's gonna supply the backbone and that's gonna be a lot of the stuff. So when you're thinking about rewiring your house for data, you gotta think about where all your computers are. And that particular piece of equipment is loud and hot. So you wanna use a closet or maybe somewhere that's gonna have a little bit better ventilation than a closet if you're dumping a lot of heat into that closet because there's not a lot of breathability, not a lot of airflow. A basement might be okay, but maybe there's water or moisture issues you'd have to worry about. Although if you're running a dehumidifier, this equipment can have a dehumidification effect because it's adding heat to your basement, if you think about that. But you also think about other devices, PoE devices. Now, in addition to phones, we also got PoE cameras. This is a hike vision that's been flashed to not be dangerous or anything like that. Also PoE devices like the Raspberry Pi that I've covered before. And the place where you put your PoE switch, power over Ethernet switch, may be different from where you put your 10 gig backbone switch because your computers may be in a different place than your DVR and some of your other networking storage. That's totally fine. As you think about where you want physical hardwired data ports, you can also think about what location minimizes the amount of work and headache that you have to do even before you run the lines. Now you can run the lines through the walls. I'm going to show you how to do that. You can also run it on the outside of the building through chases or conduit. I'll show you a little bit about that. But thinking is the first thing that you do because you're going to make a mess. You're going to look at some tools and make a horrible mess, a lot of horrible messes. And you can sometimes avoid making a horrible mess if you just think things through. First up, tools. Yeah, welcome back to the old basement. Tools, so many tools. What do you need? First, you need a good tape measure. A tape measure will let you measure distances of things, and it is a lot better than guesstimating, especially if you have to figure out where a wire goes. Now, if you have attic access and basement access, you are mostly gonna have no problem wiring your house for data. It's really not gonna be a huge deal to run extra data lines. I'm running data and electrical at the same time. Got an electrician friend helping me out. We're doing everything to code, as far as I know, pretty sure. Not my area of expertise, but hey, I can at least learn a thing or two. So running data, it's something I did in my teenage years. Yes, when I was a teenager, I was a wire monkey, basically. Haven't done that in a long time, but hey, I can do that during the quarantine and save a few bucks because it's time. So this is a drill bit. This is a 3/4 inch drill bit, which is more than you need for data. But this is great for running electrical lines as well. But it's also super long to get into otherwise inconvenient places because we're gonna drill up through the floor inside the wall so that you don't see the hole. And then we're gonna meet it at a right angle through the wall. So basically we drill up through the wall. We can use a powerful magnet. Well, not in this house because I've got 1.5 inch thick plaster, but normally you can drill up through the wall and use a really powerful magnet, find this bit in the wall and confirm that you're in the place that you think you are. The way that you start that process is with a tape measure. What we've done is taken a tape measure and we've measured off of that wall. And this wall is supported by a joist in the basement that runs the whole span. Now, we can trust that carpenters from 1909, you know, not everything was square, but it's square enough and the distance is enough that we can use that as a reference. So instead of drilling down, I drilled up. You use your stud finder to find your minimum and maximum distance. And you shoot for the middle. And if you're within a couple of inches or you get some obstacle or something in the basement, come to the next column. Come up through the wall and then cut your box for your network outlet or your electrical outlet or whatever the case may be, and you'll be all set. It's really not super complicated. It's just using a tape measure will really save your butt because a tape measure is an incredibly useful thing. And so here the electrician and I have done a little bit of work already. This is going to be an electrical outlet, but if I wanted to put a network outlet here, it's really the same process. I'm going to measure off of that wall a certain number of inches or a certain number of centimeters or a certain number of meters with fractions. And then I'm going to drill a hole up through the middle of this wall. Hopefully I don't miss. And then I'm gonna cut a box so that I can put in a network cable, or in this case, the electrician can put in an electrical outlet. Take a tape measure and you measure off of the benchmark and come back, say, 4 feet or 6 feet or 8 feet, an exact measurement. And then you find the same reference point on the first floor. Now, sometimes the walls aren't in the same place. Maybe the house will stick out over the basement, or the basement, like in my case, the basement is not quite as big as the footprint for the house. This is basically a glorified root cellar, a place to put some equipment and stuff like that. So the basement really isn't as big as the entire house. And so if I measure off of, say, that wall down there, it's not gonna be exactly the same number as if I measure off the outside wall upstairs. But you can look for something that comes through the floor, things like air conditioner vents or pre-existing electrical lines or pre-existing conduit, and say, okay, this piece of conduit is this many inches from that wall. On the other floor, it's this many inches from that wall. You can do a little math and figure out exactly how far away things are from that piece of conduit. So if I want an electrical outlet on the same wall, I can come back, say, 2 feet from that, and I can come down here and come back 2 feet from that as well. But you can also measure from that reference, and so you can drill up and go through. Now, how do you get the wire through? You just stuff the wire. Well, wire is not super convenient. These are fish rods. This is fish rod and fish tape. So fish rods are pretty cool because they're a little bit bendy, and you can push them, and you can also screw them together. So, put my drill bit down. So we've got two of these bendy boys. I'm just assuming their gender. They screw together like this, so you can put them together in the wall or crawl space or anything like that. And then that's pretty much it. Once you get these through, you can grab a hold of it. You can tie off a wire to the end. They actually make little screw-in things that'll grab hold of data wires or even electrical wires. And you can run it through however you want. This is fish tape. Fish tape's a little bit different than fish rods in that you can push it one way, but it's super bendy the other way. So depending on what or where you're trying to fish and what you're trying to fish around, this can actually be really handy. Plus you can also rotate it like this, and if it's stuck on something, this end will just go super flappy bendy, and you may be able to find a way around it. So like the fire breaks, which is the worst thing that you could run into, and it's something I'll talk about in a second. This is sometimes a useful tool because you might be able to find a way around the fire break if the fire break isn't perfectly, through there. Otherwise, you're probably gonna be opening up the wall to drill a hole. Now, I'm not gonna cover actually fishing a wire through the wall from like the top or bottom. If you need more information on that, check out Tom Lawrence Tech. He's got a great video on, like the easy and then like the insulation filled where you can use fish rods. And then he's also got another video where they have a fire break and then they like use the super long bendy rod to go straight through. And there's a technique where if you back off, maybe you won't do it. But in this old house, because the fire breaks are at an angle, you're gonna come through the plaster, like pretty much. So could be worse. Other tools that are useful, stud finder. So if you're measuring off of your benchmark and you want to be sure that you get it right in the middle of that stud cavity, most studs are on 15-inch centers here in the US, sometimes 24-inch centers. You can use a stud finder and mark that off on your wall and measure where the studs are so that when you come down to the lower level where you're going to push your wire up through, you can figure out what you're going to avoid. Now normally I recommend cutting a hole in your wall and then using a right angle drill bit or a long drill bit and going down through the wall that way. That way you can't possibly screw up, and if you do manage to hit something down here, like it's usually another piece of wood, you can back off and try it again. The reason that doesn't work in this house is because every wall on the first floor is sistered to another joist in the basement. So when we're talking about I'm going to come down through the center of the wall, I've only got about 3/4 of an inch to work with because they've got two 2x12 joists that are running to support all of the internal walls in the basement. So check it out. So here on the first floor, right above this, there's a wall. And so my target is this tiny gap because you don't want to mess with these joists that are load bearing. Again, if you're completely lost, you definitely want to consult a contractor or something. But there's a really thick wall sitting on top of this mess on the first floor. And so this target is too small for me to hit coming down, but it's really easy to hit for me going up. And I've used the measurements, the tape measure, to make sure that my wall does sit perfectly on this load-bearing structure that's here. And so just like that, I'm able to drill a hole, fish down my modern electrical wiring, and I'm good to go. Now this is the corner of the basement where I've decided to locate my alarm panel, which has a doubly redundant connection. I've also got my fiber optics and new electrical to be able to support whatever. We're basically underneath the stairs to the basement, but this is out of the way of any kind of water lines or water seepage. I've got electrical, it's basically out of the way in case I ever decide to do any work down here to finish this up more, you know, to make it a little bit more habitable, let's say. The dust is pretty well controlled in this corner, so I don't think the equipment's gonna soak up a lot of dust. And I think if there's a lot of heat generated in this corner, it's got room to breathe. So, you know, think about all those things. It just so happens that I'm gonna have my main switch and my PoE switch and my alarm panel all in one place. But again, that's not something you necessarily have to worry about, because you could put those things in different places. And in fact, I recommend it. Now, sometimes you're unlucky. So in this case, we've opened up this wall because, well, there's a bit of plumbing to repair. This is, you know, there was cast iron here. Now it's nice PVC because cast iron, good Lord. But this is a fire break. You'll usually find these about 48 inches up. It again varies. And depending on where you are, code, you know, check with your local licensed contractor and all that, all the standard disclaimers apply. Even for running data, if you drill a hole in this, you're supposed to fill it with caulk or another material that will create an air barrier. The reason for this is because this can have a chimney effect. If the building catches on fire, this can turn into an air cavity, which will actually cause hot air to come up through the wall, and it just turns into a chimney effect. Things will actually burn a lot quicker. So you see things like this inside the wall in very old and very modern construction, but not a lot in the middle. Like, they did away with it in the 70s and 80s. It was like, ha, 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 super asbestos is super flame retardant. Yeah, it's also gonna give you lung cancer. So when you take it out, fire breaks are good stuff. You don't wanna take them out, you wanna keep them. And especially you might be required to keep them. So if you're gonna drill through the wall with one of the long drill bits or using a fish rod, and you know, have a sound like that, you may have no choice but to cut at least a section of wall out so you can drill through it. Now, sometimes the fire breaks are horizontal instead of being turned like this one is. In this house, I got super unlucky. It's really hard to drill a hole through a fire break like this. With a drill bit on an extension, it's pretty much gonna mess up your wall on either side, so just be prepared for that. Now, we talked about the first floor. What about the second floor? Well, that's where this old chimney comes in. So this chimney is used as a cooking exhaust, but in terms of like exhausting anything else, not really. Most of the time in old houses, next to the chimney is usually a safe or a safe-ish place that you can run a chase from the basement to the attic. See, the way that we're coming up through the floor in the basement to the first floor, we can come down through the attic to the second floor. So we run all of our wiring basically from the attic down, but we gotta get all our wiring to the attic somehow. A chimney, it's gotta go all the way through to the roof. So generally, if you look around the chimney, you can usually find a place to get a conduit if you don't, you know, have a pre-existing chase or just an open wall. In my case, I've got a 15-inch by 8-inch chase that used to be a laundry chute, because this is a laundry, you know, there's a laundry room on the other side. Well, we don't really use the basement for the laundry anymore, so we're gonna use that chase to run electrical, plumbing, and a large 4-inch conduit for Cat 6 cabling. So the entire second floor, Cat 6, no problem. Sometimes there's just no way. You have to go on the outside of the building. Well, there's stuff you can make for that. You can put your wires in a plastic PVC pipe or a PVC electrical pipe. I mean, it's gray or white. And then put a metal box around it. It doesn't look completely horrible. It's okay. And if you do it metal and you ground it, you get a little bit of lightning immunity. Or you can use metal conduit, of course, but that's really expensive and a pain in the butt to paint and get paint to stick and also be all weather. Now with our data lines in the attic, we can come down the wall just the same way that these electrical conduits are run. See, there used to be a wall here, there's not now. So there's an electrical conduit here. You know, all the old wiring has been removed because it's super dangerous and it's all unhooked. Everything's gonna be standard, it's fine. But because this conduit was already here, we don't really have to open up this wall in order to do the electrical. Now the irony is for the video, yeah, the wall's open obviously, but that's because there's gonna be a door here. and also another data outlet, sort of right there on this side of that stud. So yay, hardwired data. I mean, for any computer that you're at for more than 15 minutes, run a hard line. Plan on hard lines for cameras, wireless access points to give you good coverage, and entertainment centers. Your TVs, your stereo, anything like that, hardwire it. Don't make it wireless. Trust me on this. With electrical work, you definitely don't want to do electrical work without a permit or having your master HVAC or anything like that. You definitely want to pay attention to local codes. There's different rules you have to follow, that kind of thing. But for data wiring, generally there's not too much in the way of rules. There are a couple. One is if you run a wire through a space that breathable air goes through, you have to use a plenum coating. And that's because if the wire burns, it won't give off toxic fumes. So if you're going to reuse some ductwork, which you can run networking wire through ductwork if you don't have any other choice, I don't recommend it. But if you do that, you've got to use plenum wiring. That's code in just about everywhere, but you may also have local code, so double check that. Now, 1909 was a long time ago. The National Electric Code, the modern National Electric Code, was not even a glimmer in the great-grandfather's eye of the person who wrote the spec. Sometimes we get lucky though. So normally a house like this would have knob and tube wiring, which means that you got to completely gut everything. Well, the guy that built this was either a genius or very lucky because he put conduit everywhere. So this light switch and a lot of the electrical outlets and some of the outlets that we're repurposing for data have a conduit that runs right where we need it to. So I've been able to pull modern Romex electrical lines to this light switch. And modern electrical code requires that each light switch is not just flipping the hot wire on and off, which is how they used to do it from like the 70s up through the early 2000s. There needs to also be a neutral in here as well. And get this, the reason they changed the National Electric Code is so that you could have smart light switches, because otherwise it's hard for these light switches to have parasitic power, because then they have to pull power from ground or complete the loop through ground, and that's a story for another time. Short version is that sometimes you get lucky. We don't have to open these walls at all, not for data, because we can drill through the wall and not make a huge mess, but also not even for electrical, because we can pull modern wiring through the existing 1-inch conduit. Here's some of the pre-existing conduit I was talking about before. So it's been really easy to just fish new modern electrical wiring through the old conduit, and the boxes are still up to code, so just get some wire nuts on this, get it inspected, we'll be good to go. Sometimes in a room like this, you've got no choice. So this room only had one electrical outlet, and getting around the fire breaks is tricky. One trick is you can come around the door jamb sometimes because that's a little more open. We're gonna open up the bottom of the wall to be able to fish electrical line. Yeah, the TV, I don't know. The TV was just sort of here. It's too hard to get down the stairs. But you open up the wall like that, and it makes it easy to get your electrical and data lines in. And it's pretty easy to patch with drywall. Sometimes accidents happen. I'm gonna go hang that access point, and then there's not really ceiling there anymore. But a ceiling is a super convenient location for locating an access point because it's gonna give you really good coverage, even in a house like this where there's so much lath and plaster. Now once you get your holes cut, neatly of course, as neatly as you possibly can, neatly with a reciprocating saw, I'll talk about that in a second, you need a box. A box makes your work nice and neat. Now, most hardware stores, Lowe's, Ace Hardware, your local hardware store, sell these. This is a warning, low voltage class 2 use only. This is a Claron, I think that's how you say that. These are awesome because it comes like this, get your cutout. It's got a pretty good sized lip on the side. It's like 1/2 centimeter, 1/4 of an inch, a little more than 1/4 of an inch. You cut your box out, your hole, you shove that in there, you tighten these 2 screws, these little things flip out in the wall and grab a hold of the wall. And so these are actually pretty sturdy. They work best with drywall. They will work with plaster as long as your plaster is not super thick and 110 years old. This will work fine for low voltage. You don't want to put electrical outlets in this. That's what that means, class 2. Again, work with somebody that knows what they're doing. Don't DIY that. I mean, you can DIY the data, but not anything other than data. So this is great. This will hold like 6 gang data outlets. If you need 6 Cat 6 lines, this will do it. And we'll talk about tools and termination for that, but mainly you just gotta run the lines for Cat 6. I don't recommend Cat 6. Cat 6 has better noise immunity than Cat 5. Yeah, you can do gigabit on them both. And yeah, you can even do 10 gigabit on Cat 5e on short runs, but just go for the extra expensive Cat 6. This is gonna be a headache. You don't want another headache a few years from now. You could do Cat 6a. Cat 6a has slightly better lightning immunity, but the lightning immunity from Cat 6 is so much better than Cat 5e, at least in my experience, that you should just go ahead and opt for the expense of Cat 6 as opposed to Cat 5e. This is my favorite old world box. This is a MSB1G. So this is a box that comes with 2 screws. These are kind of pricey, even in 20 unit quantities, but these boxes are awesome. These are, strictly speaking, these are meant for electrical. But when you're talking about modern and relatively modern construction, there's this idea of a vapor barrier. You have, plastic for outside walls. You have plastic sometimes on the inside walls to control the flow of moisture. This is a big open hole in your wall. And even when you screw this down, even with a faceplate, it's going to breathe a little bit around the hole depending on the construction of your home. This is a lot more easy to address because you can put this in and you can do a little silicone bead around the edge of this. This is much thicker plastic, this is much better. And you can also bead where your wire comes in, your Cat 6 wire. Now, you can use electrical for these. It's got cutouts for both 14 gauge and 12 gauge. And it's a pretty deep box, so you get a lot of room for wires so you can get a nice bend radius without compressing your wires or doing anything crazy. These boxes are also nice if you're mixing, say, networking wires with HDMI. You can use a Dremel tool or something like that to cut out the back and be able to fish an HDMI cable through the wall. And then these big screws mean that this is going to grab onto a stud, not your drywall, not your wall material, which is, in the case of plaster, is actually very fragile. Any kind of flex is eventually just going to cause it to fall out. So this is a much better choice in almost all scenarios for data, wiring, anything like that. I'll have a Google link for these below, but as with most things, these are so nice, mostly your local hardware store doesn't carry them. Or if you do, if your local hardware store does carry these, you probably live in a place where people aren't completely stupid. So this is what the orange box looks like when it's in. You got to take care to make sure that you're cutting the boxes straight and that everything lines up. And if you do overcut, you really should mud this little gap here, at least a little bit of silicone. If you use the gray box, you're not going to have those kind of problems because it's going to be affixed to a stud. It's going to be straight every time. One tool I'll give an honorable mention that you don't have to have, but that is nice to have, is one of these DeWalt, like, vibrating saws. I don't really know what to call it. Cordless oscillating multi-tool. So this little thing, this is super easy to cut a really accurate and really, just sort of idiot-proof way to cut out boxes, to cut out the wall, to cut out the plaster, although you will change bits a lot. So you should have a plaster bit because otherwise your wood bits are gonna get super dull. And it's kind of hard to find a plaster bit, but there's some, cottage industry folks on eBay. This thing is awesome for cutting out boxes without making a huge mess. And if you do screw it up, you can use the oscillating tool to put the piece that you cut out back. If you use a regular drywall saw, it can be hard to patch it. And with this, the cutout is so thin that you can use a little bit of patch tape and fix your hole in case you make a mistake. Or if you're in the fire break situation, you can cut out right where the fire break is in order to do a notch like this, or a drill, or drill a hole, whatever, right in the wall. And it does make patching a little easier because you can use that wall material that you got from cutting this out in order to repair whatever it was. I'm Wendell. This is another episode of this house that happens to be old with, Linux edition. I'm signing out. I'll see you in the Level 1 forums.